Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. The worst thing that can happen on YouTube is that one of your videos gets panned. Except today, because we're going to take a look at pans. And not just any old pans, like the sort you might find in the kitchen. No. We're going to look at pan choice in a DSC. After watching the video, you'll have new knowledge to allow you to get better information from your data. And you'll be one step further on your journey to becoming a DSC expert. So, get yourself a drink. I don't usually have a lid on mine, but as you know by now, I'm in the lab, so whether I have a lid or not is kind of irrelevant. And let's get started. I think you remember that in a DSC experiment we heat or cool sample and reference materials between two temperatures at a fixed rate. The sample material in particular is usually a powder, and we need some way of encapsulating it such that it stays in place in the furnace, is located in the right place for the instrument to measure it, and can be removed after the experiment is finished. We do this by placing the sample into a pan. Pans come in all shapes and sizes, depending on the design of the DSC and the sample being studied, and can be made from a number of different materials. Given this wide variety of pan type, it is therefore essential that you pick the right pan for your sample. Pan size is going to be specific to your particular DSC instrument. I have a number of DSCs, and they require different size pans. One uses small pressed metal pans that can hold around 5 to 20 milligrams of sample, while another has stainless steel pans that can hold around 1 milliliter of liquid. For the purpose of this discussion, I am going to assume that you are using a DSC that takes pressed metal pans, as these are by far the most common. My instrument uses pans that look like these. They are quite small, as you can see. There are a number of decisions you'll need to make when selecting pans. If they're available in different materials, then selecting the right material for your sample and budget is the first decision you need to make. The cheapest option, and hence the one that I use, is to use a pan made of aluminium. But pans may be made of other metals such as copper, gold or platinum. Aluminium pans are cheap and so tend to be used only once before being discarded. But I think you might imagine it's better to clean and reuse gold or platinum pans. And why are pans usually made of metal, I hear you ask? And the answer to that very good question is, although we want the DSC to control the sample and reference temperatures very accurately, we don't actually measure the temperatures of the sample and reference materials directly. That would mean having thermocouples directly in the pan. Rather, the temperature is measured directly under the pan, and we need to assume that the sample and reference materials are at the same temperature as the instrument. The pans are made from metals with high thermal conductivities. That is, they conduct heat very fast, to ensure there is as little temperature difference as possible between the sample, reference, and the instrument. Should you always use an aluminium pan? That depends on your sample. The melting point of aluminium is 660 degrees centigrade. So if you need to heat your sample to a temperature above this, definitely don't use aluminium pans, as they will melt all over your DSC. Copper, gold and platinum pans can be heated to 725 degrees centigrade. If you need to heat above that, then you need to consider switching to a non-metallic pan, such as one made from graphite or ceramic. But that's kind of unusual for pharmaceuticals. Another reason to think about the material your pan is made from is if your sample can form an alloy with it. Most pharmaceutical materials are small molecular weight organic compounds, so alloying with a metal is unlikely. But it happens that indium, which is often used as a calibration standard, forms an alloy with gold. So if you're using gold pans, you shouldn't use indium as a calibration standard. So that's all we need to think about when considering pan material. The next consideration relates to the pan itself and whether it should have a lid or not. You might not think that's important at all, but it is for many reasons. In general terms, I think that, unless you're specifically interested in how your sample interacts with the atmosphere, you should make sure your pan has a lid. The lid will be made of the same type of material as the base pan and can be sealed such that it is airtight or not airtight. The principal reason for using a lid is that to get the best data from the DSC, you want the sample and reference to exchange heat with the instrument as fast as possible. And having a lid on the pan means that the sample is surrounded by a good thermal conductor on all sides. The next question is whether the lid should be compressed onto the sample such that there's no air gap above it in the pan. If your sample doesn't melt or vaporize, then I would suggest this is the best option. Air is a great insulator, so having the lid in direct thermal contact with the sample will give you the best data. However, and this is a biggie, if your sample does melt or vaporize, then its volume will increase dramatically. And if you've left no room for expansion within the pan, then there will be a build-up of pressure during a phase transition, which can ultimately burst the pan. This is not good for two reasons. One is that the burst itself will cause a spike in your data, and the other is that your molten or gaseous sample will coat the inside of your instrument. So, if you think your sample may expand, make sure you use a concave lid that allows room for expansion. Should you crimp the lid such that the seal is airtight? We call that a hermetic seal, or not. Unless your sample oxidizes, so you are trying to minimize exposure to air, I think it's best not to have a hermetic seal. Even though you may have room inside your pan for the sample to expand, as it does so, the air in the pan above the sample will compress, building up a pressure which again may cause the pan to burst, putting a spike into your data. And in any case, even if your sample oxidizes, you can use nitrogen as a purge gas, more on that in a later video, which will keep oxygen away. So I would advise not using hermetic pans. Unless, that is, you make a small hole in the lid of your hermetic pan with a pin. Although it sounds slightly mad to make a pinhole in a hermetically sealed pan, there is actually method in my madness. The pans are usually aluminium, which being soft will bend when you press a pin into it. So as you make a pinhole, you'll also make an indentation in the lid. This has two benefits. One, the pinhole allows gases to escape from the pan, preventing a buildup of pressure. This should mean that the pan cannot burst open. And secondly, the indentation in the lid forms a well that any sample can collect in should it melt and expand out of the pan. This keeps any liquids from spilling over onto your instrument. If you use a non-hermetic or not airtight pan, the lid is only loosely resting on the base of the pan. So should the sample melt and expand, it can leak out the side and hence damage the instrument. So my advice is to use a hermetically sealed pan with a pinhole for all experiments unless there's a good reason not to. In the next video, we'll discuss a particular type of experiment where it is useful to repeat measurements with and without a pinhole pan, but we don't need to get into that here. Remember then that different instruments take different types of pan, so see what are available for yours. Pans are made from a range of materials that are usually good conductors of heat. The cheapest option is an aluminium pan. These are single use and disposable, but aluminium melts at 660 degrees centigrade. So if you need to heat that high, you should consider copper, gold or platinum pans instead. Some metals will form alloys with the pan. Indium with gold is one to avoid, in which case graphite or ceramic pans can be used. Samples should ideally be encapsulated in a pan with a lid, and I think the lid should be hermetically sealed with a pinhole, but that's a personal preference. Okay, that's all you need to know about pans. Should you wish to, you can pan this video in the comments section. Or, preferably, you could hit the like button and consider subscribing. That would be fab. In the next video, we'll look at some tips for good experimental design, so I hope you'll join me for that. Otherwise, thank you so much for watching, and I'll see you again soon.